For this lesson, I've created both a simple to-do interface and a to-do object with some properties. Now let's pretend we want to write a prop function that takes an object and a key and returns the corresponding value. The idea is that we can use our function like this. We can say prop of to-do, and we want to get the ID property. Of course, we can do the same thing for text and also for completed. Right now, all of the variables we just created have the type any. And that is because the signature of the prop function takes any object, any key, and returns any value. So how could we type the prop function a little better? First, we're going to find a good solution for the specific to-do type, and then later we're going to develop a generic solution. So let's go ahead and require object to be a to-do, and let's require key to be any of the strings ID or text or completed, because those are the only valid property keys that we have defined in our to-do interface. This type information alone is enough for TypeScript to give us better return type information. So the ID variable is typed to be a string or a number or a boolean, and the same goes for text and completed. This is because the prop function now returns either a string or a number or a boolean. We only accept these three keys, ID or text or completed, which means we can only get one of the following values. If we pass in the string ID, we would get back a number, whereas if we pass in text, we would get back a string, or if we pass in completed, we would get back a boolean. That is now encoded in the type system. Also note that this prevents us from accessing properties that don't exist. So if I were to do something like this, I would get a type error saying that argument of type dueDate is not assignable to a parameter of type ID or text or completed. We're trying to use a key that doesn't exist, so we get a type error, which is great. Now, it's a little cumbersome to spell out all the property names, and it's also not that maintainable, because if we add another property later, we will have to fix that union type here. What we can do instead is use the keyof operator. Keyof some type represents all property names of that type as a union type. So here, keyof to-do stands for ID or text or completed. Our prop function is still specific to to-dos. Let's go ahead and make it generic so we can use it with other types as well. We're going to create two new type parameters called t and k. T is the type of the object, and k is the type of the key. Now there is one restriction that we have to impose, and that is that k must extend key of t. This means that k must be any of the keys that the type t defines. Now we get even smarter type inference. ID is now typed to be a number. Text is now typed to be a string, and completed is now typed to be a boolean. All of this works because the prop function is now inferred to have a return type that is written as t and then k in square brackets. This is called a lookup type or indexed access type, and we can also explicitly add a type annotation here. Using a lookup type, we can find out what type the property k has within the type t. Here's an example. We can create a type alias called toDoID, which is equal to the type of the ID property within the to-do type. So we basically look up the type of the ID property within the to-do type. And if we check line 2, we can see that the ID property is of type number. And therefore, toDoID now stands for the type number. We can do this for other properties as well. For example, let's do it with the text property. toDoText stands for string. We can even union several property keys together, which makes this thing really interesting. toDoText or completed stands for either a string or a boolean, because that is the union of the two property types up here. Now notice that our prop function is no longer specific to our to-do type. we've replaced every occurrence of to do with t and k, so we can use this function with any type we like.